Advanced Statistics Assignment Help. For any help regarding Advanced Statistics Assignment Help, visit https://www.statisticsassignmenthelp.com, email info@statisticsassignmenthelp.com, or call us at +1 678 648 4277. 1. Fred is giving out samples of dog food. He makes calls door to door, but he leaves a sample, 1 can, only on those calls for which the door is answered and a dog is in residence. On any call, the probability of the door being answered is March 4th, and the probability that any household has a dog is 2/3. Assume that the events door answered and a dog lives here are independent, and also that the outcomes of all calls are independent. A. Determine the probability that Fred gives away his first sample on his third call. B. Given that he has given away exactly 4 samples on his first 8 calls, determine the conditional probability that Fred will give away his 5th sample on his 11th call. C. Determine the probability that he gives away his 2nd sample on his 5th call. Probabilistic Systems Analysis. Problem. C. Determine the probability that he gives away his 2nd sample on his 5th call. D. Given that he did not give away his 2nd sample on his 2nd call, determine the conditional probability that he will leave his 2nd sample on his 5th call. E. We will say that Fred needs a new supply immediately after the call on which he gives away his last can. If he starts out with 2 cans, determine the probability that he completes at least 5 calls before he needs a new supply. F. If he starts out with exactly m cans, determine the expected value and variance of dm, the number of homes with dogs which he passes up because of no answer before he needs a new supply. 2. Each night, the probability of a robbery attempt at the local warehouse is 1/5. A robbery attempt is successful with probability March 4th, independent of other nights. After any particular successful robbery, the robber celebrates by taking off either the next 2 or 4 nights, with equal probability, during which time there will be no robbery attempts. After that, the robber returns to his original routine. StatisticsAssignmentHelp.com. A. Let K be the number of robbery attempts up to, and including, the first successful robbery. Find the PMF of K. B. Let D be the number of days until, and including, the second successful robbery, including the days of celebration after the first robbery. Find the PMF of D, or its transform, whichever you find more convenient. During a successful robbery, the robber steals a random number of candy bars, which is 1, 2, or 3, with equal probabilities. This number is independent for each successful robbery and independent of everything else. No candy bars are stolen in unsuccessful robberies. C. Let S be the number of candy bars collected in 2 successful robberies. Find the PMF of SD. Let Q be the number of candy bars collected in 10 robbery attempts, whether successful or not. Find the PMF of Q, or its transform, whichever is easier. Find the expectation and the variance of Q. 3. You are visiting the rainforest, but unfortunately your insect repellent has run out. A. As a result, at each second, a mosquito lands on your neck with probability 0.2. I. What's the PMF for the time until the first mosquito lands on you? 2. What's the expected time until the first mosquito lands on you? 3. If you weren't bitten for the first 10 seconds, what would be the expected time until the first mosquito lands on you, from time t equals 10? B. Instead, imagine the rainforest had only 1 mosquito, which arrived in the following way. The time of arrival is exponentially distributed with lambda equals 0.2. I. What's the expected time until the first mosquito lands on you? 2. If you weren't bitten for the first 10 seconds, what would be the expected time until the first mosquito lands on you, from time t equals 10? 4. A particular medical operation proves fatal in 1% of the cases. Find an approximation to the probability that there will be at least 2 fatalities in 200 operations. StatisticsAssignmentHelp.com. 5. Arrivals of certain events at points in time are known to constitute a Poisson process, but it is not known which of two possible values of lambda, the average arrival rate, describes the process. Our a priori estimate is that lambda equals 2 or lambda equals 4 with equal probability. We observe the process for t units of time and observe exactly k arrivals. Given this information, determine the conditional probability that lambda equals 2. Check to see whether or not your answer is reasonable for some simple limiting values for k and t g1. A wombat in the San Diego Zoo spends the day walking from a burrow to a food tray, eating, walking back to the burrow, resting and repeating the cycle. The amount of time to walk from sex. The wombat, with 1/3 the burrow to the tray, and also from the tray to the burrow, is 20 probability, will momentarily stand still, for a negligibly small time. During a walk to or from the tray, with all times being equally likely, and independently of what happened in the past. A photographer arrives at a random time, and will take a picture at the first time the wombat will stand still. What is the expected value of the length of time the photographer has to wait to snap the wombat's picture? StatisticsAssignmentHelp.com. 1. A successful call occurs with probability A. Fred will give away his first sample on the third call if the first 2 calls are failures and the third is a success. Since the trials are independent, the probability of this sequence of events is simply B. The event of interest requires failures on the 9th and 10th trials and a success on the 11th trial. For a Bernoulli process, the outcomes of these 3 trials are independent of the results of any other trials, and again our answer is solutions. C. We desire the probability that L2, the second order inter-arrival time, is equal to 5 trials. We know that PL2L is a Pascal PMF, and we have D. Here we require the conditional probability that the experimental value of L2 is equal to 5, given that it is greater than 2. StatisticsAssignmentHelp.com. E. The probability that Fred will complete at least 5 calls before he needs a new supply is equal to the probability that the experimental value of L2 is greater than or equal to 5. F. Let discrete random variable f represent the number of failures before Fred runs out of samples on his MTH successful call. Since LM is the number of trials up to and including the MTH success, we have f equals LM minus M. Given that Fred makes LM calls before he needs a new supply, we can regard each of the f unsuccessful calls as trials in another Bernoulli process with parameter r, where r is the probability of a success, a disappointed dog, obtained by. We define x to be a Bernoulli random variable with parameter r. Then, the number of dogs passed up before Fred runs out, dm, is equal to the sum of f Bernoulli random variables each with parameter r equals 1, 3, where f is a random variable. In other words, note that dm is a sum of a random number of independent random variables. Further, f is independent of the she's since the she's are defined in the conditional universe where the door is not answered, in which case, whether there is a dog or not does not affect the probability of that trial being a failed trial or not. From our results in class, we can calculate its expectation and variance by StatisticsAssignmentHelp.com. 2. Define the following events. Event R. Robber attempts robbery. Event S. Robbery is successful. Define the following random variables. X. The number of days up to and including the first successful robbery. B. The number of candy bars stolen during a successful robbery. C. The number of days of rest after a successful robbery. StatisticsAssignmentHelp.com. Note that x is a geometric random variable with parameter 320, the probability of a successful robbery on a given night. Also, it is given that b is uniform over 1, 2, 3, with probability 1 each, and that c is uniform over 2, 4, with probability 1 each. 2. A. Observe that since the probability that any given robbery attempt succeeds is 3, 4, the 3 random variable k is geometric with parameter p equals 4. Thus, B. We will derive first the PMF, and then the transform of D, The number of days